frame to frame, moving point within the frame. Okay. Ini video so I skip lah. Oh, lupa bagi salam lah. Assalamualaikum and good day. Good afternoon. Okay. This is robot type. Boleh dengar? Semua boleh dengar?
Boleh.
Okay, robot type. So kalau robot type, kalau please draw ataupun sketch 3P robot type. 3P ni maksud dia prismatic lah. Prismatic ni that mean your motion is linear. So you ada X, Y dan Z lah example. So 3D. So this one 3D. And R2P that mean you have one revolute joint and two prismatic joint. So this is cylindrical. This is Cartesian. This is cylindrical. And this is spherical. Two rotation or two revolute joint and one prismatic joint. So spherical. 3R or more. So we call articulated robot. So 3 revolute joint or 3 rotation revolute joint. So we call articulated. And this is Scara robot. You have 2 revolute joint and 1 prismatic. Okay, this is the shape of working envelope. Shape of working envelope. So this is Cartesian. So this is the shape of Cartesian working envelope. This is cylindrical robot, cylinder. So this is spherical and this is articulated. So a Cartesian doesn't mean that you can make a square shape. Any shape that within the working envelope you can develop. So that's why if you see 3D printer, their concept is like Cartesian robot, but you can print all the shape, very detailed shape. If you print your face or a very detailed shape, you still can print, but within this working envelope. You still can plot a curve or circle. Doesn't mean that this is Cartesian moving in linear direction. He cannot print a curve shape. No, he can print a curve shape. Any shape lah, he can print any shape. So this is how we control a robot. For example, if you want to move from point A to point B, or once you rotate any of these motor or joint, so you can define where is the point B. For example, where is point B? Or you want to move point B, A to B, exactly at this B point, B location. So what is the angle that motor need to be rotated also can be defined using kinematic. In this kinematic, in this robotic arm, we use the homogeneous transformation metric and DH method. DH method. So you learn here 2 type of kinematic for robotic arm. So this one is not only point, but you also need to calculate orientation, because you need to define also your orientation of your gripper. So not only point, but including the orientation of gripper. So you need to calculate both point and orientation. So for example, if your screw inside this box, so you use a vision system, and then you detect the shape of screw here is a bit slanting, sengit So you need to instruct your robotic arm to ensure that your gripper position or orientation is suitable to pick up this screw. So you need to program the robot to ensure that the gripper is perpendicular, for example, perpendicular to the head of screw, this one. So it's not if your robotic arm cannot pick up the screw, although you have a good vision system. This is just to remind back. So where is the world reference frame? So world reference frame is 0, 0, 0 coordinate, normally at your base of your robot. So 0, 0, 0 coordinate. So all other frame will refer to your world reference frame. World reference frame. So that means from here is 0, 0, 0 coordinate, X, Y, Z. So here you will get the coordinate that your robotic arm located. And also your orientation. This one including your orientation because you have frame at your gripper. And also you have your frame at your cylinder. Maybe this is your part lah, your component that you need to pick up. And this also your box is your component to be picked up. So this is the frame. So we must know the orientation or the frame of the object. Then we can calculate our gripper position and orientation to pick up this component. So if we didn't define, how we define this frame? We define this frame based on your vision system. Based on your vision system. Or you already specific. You put say like a jig here to ensure that this component orientation is fixed. So then we put in the program the orientation or the frame of your object. So we calculate the robot based on this orientation and also the gripper orientation. So we can calculate using homogeneous and DH method to ensure that the gripper can position to align with this object to pick up. So each joint have its own frame. So for example, this is Ji, I is variable. So if this one join 1, so this one is J1. This one is J2, J3. So this is gripper. So each of the joint must have a frame because we want to control the motor. After we move a little bit the motor, then we need to define the orientation of the robotic arm. So and then motor number 3, we move a little bit, so we need to define the orientation of joint 3. And then we can define our gripper position and orientation. So each of joint that can move need to be identified. We need to put a frame lah, reference frame or joint frame. So without we calculate the joint position, we cannot define the last position of the gripper. So we not calculate properly, we cannot ensure that the gripper align with the object. Okay, if your X direction is on the left side, then we use a right hand technique. Coordinate system. So this one for homogeneous, but when we go to DH method later, we only use your Z axis, this one, and your X axis, this one. So you didn't use y-axis. In DH method, you only apply or use z and x-axis. So y-axis will be calculated automatically based on the value of x and z-axis. And this is forward kinematic versus inverse kinematic. So before this, okay, the difference between forward and inverse. So forward is that we want to find the end gripper, end tool or gripper position and orientation. We want to find gripper position and orientation after we move or we rotate each of the motor. So based on the encoder reading, so we know the angle of each joint. So we put into a kinematic or homogeneous or DH method, we can define position. For example, this is only position because we don't have Z, because Z is on vertical. So we only can see X and Y. So we only can find the position. But if we have a 3D view, so we can find the orientation of the gripper. So we put the value of theta based the input from the encoder. We put into the homogeneous or DH, we find our position XY coordinate. But inverse, we going to find the angle of each joint or the position of each joint, because this angle, because your joint is rotate. If your joint is prismatic, so we can define our distance of your joint, your motion, distance, linear motion. So you put your coordinate, and then we apply an inverse kinematic formula so we can find out our theta 1 and theta 2. This is fundamental metric. So I skip this one. Okay, this is a position in 3D view. So you have X, Y, and Z. If X to the left side, then you use a right hand. Use the right hand. So for example, this is only position because it's only point, so it's only position. You want to find the position of robotic arm. So for example, this is your robotic arm. So this position is contributed by x-axis, here, y and z. So this position is located in 3D view. So you have x value, y value, and z value. This is after transpose. So you get x, y, z. X, y, z. So if you want to find a vector p, so vector p also contain x, y, and z value. X, y, and z. This one, you have position and orientation. Why? Because you can see here frame 1, frame A, this is frame B. So frame A, Z is vertical. Now frame B, your Z is slanting on the left side. So and then we check your axis Y. So you can see Y also a bit slanting, rotated to the upward. X also have a little bit slanting to downward. So this means that it's not only one axis rotated. So this is rotation affected by maybe 3 axes. So X, Y, and Z have a rotation metric. And then for homogeneous, this one I'm going to skip because this is fundamental. So we only apply rotation metric during our calculation. So we apply this rotation metric. So this is homogeneous. We have rotation metric, we have a position coordinate, and this is 001 is a value that to be used to generate a 4x4 matrix. We put 0001. So AB, that means B in the bottom is a new location, position and orientation. And the top is the starting position. Starting position. So A and this is B. So B from A. B from A. Okay, this we have rotation, mapping, this is operator rotation, this is mapping. So this is rotational, rotate only. This is mapping. So you have axis, you have frame. Rotation about frame axis. So if you see that X from this 0 frame to frame 1, you see X rotated and you see Y rotated in the same value of angle. That means you are actually rotated on Z axis. So rotated on Z axis. If you rotate from Z axis, you must look from Z. When you look from Z, you need to have a good imagination. When you look from Z, that means you rotate counterclockwise. Counterclockwise. Same like this one. So for example, this is 0.0, for example, and then rotate. That means you're looking from Z axis. You're looking from Z axis. This also you're looking from Z. Why are we looking from Z? Because you only can see X and Y axis. When you see X and Y axis, that means you are looking from the Z axis. If you rotate counterclockwise, this one, that means you rotate positive value. Positive value. If rotate clockwise, it's negative value. This normally student will have a mistake because they make a careless mistake that where its view, where he look from the axis. So if they have made a wrong understanding, he said that this is rotating clockwise, so wrong imagination. So he said that this rotate clockwise, so he get negative 90, for example. For this one, maybe negative 30. The right angle is positive 30 because we rotate counterclockwise. Counterclockwise, we get positive 30 degree, for example. Okay, this is the important formula. Important formula for homogeneous transformation matrix and also for DH method. normally this formula will be given in the quiz or exam. I will give this. And the other formula that you need to remember, you need to apply is translation metric. Translation is 1, 1, 1, 1. So because you use a 4 by 4 matrix, so you have x, y, z, x, y, z, and then the rest is 0. So the diagonal is 1, 1, 1, 1. So that one is translation metric. This is rotation. If you rotate at z-axis, so you apply this formula. If you rotate on y-axis, so you apply this formula. And if you rotate x-axis, you apply this formula. Any question or not? So you need to use 4 metric formula lah. Rotate y, rotate x, rotate y, rotate z, and translation. Translation metric. How many students now? 95. It's almost full class. Ada question tak setakat ni? Awak akan guna 4 metrik 4 metrik sahaja di dalam homogeneous. Cuma nanti cara tulis je lah. Cara tulis kalau mapping dari kiri ke kanan. Cara tulis metrik dia. Kalau awak nak refer ke word reference frame saja, so dia tulis dari kanan ke kiri. So multiply matrix, so kita dah test dah last time. Kalau awak multiply kiri ke kanan pun awak dapat value yang sama, dari kanan ke kiri pun awak dapat value yang sama. Cuma kalau awak nak buat mapping, so awak kena letak awak punya step, motion step tu, matrix awak dari kiri ke kanan. Tak kita tunjuk. Kalau nak mapping. Mapping between frame to frame. So dia kena letak dari kiri ke kanan. Ingat ada soalan tak?
Tak ada.
Tak ada. Jangan lena ke? Sudah. Okey, ini kalau buat mapping lah. Kita boleh kita tengok contoh lagi. Mapping, changing description between two frame, operator changing description between the frame. Operator changing description within the frame. Mapping, changing description between two frame. Ini rotational operator dalam frame. Ini between two frame. Mapping. Okay, ni 3x3. Ini belum masuk homogeneous lagi. So yang ni cuma nak tunjuk only to show how we apply a rotation matrix using this formula. But it's not combine position and rotation in one matrix yet. Not combine yet. This is only rotation, and then the other example, rotate on Y, rotate on Z, rotate on X, and then translation individually. But if you apply homogeneous, they are combined because they use a 4x4 matrix. They combine all in one matrix. All in one matrix. Nah, ni example lah. So kalau rotate from point 1 to point 2, point 1 to point 2, so you have a rotation matrix. Rotate on which axis? Rotate on X axis. So you must have a good imagination of 3D lah. So this one rotate on X axis. So the different, the changing value coordinate will be between X, Y and Z lah. Y and Z, because you rotate on X axis. And you don't have value for X because your line, your position is on the X and Y axis. Y and Z axis. x is 0. So you don't have x value. So this one rotation, and this is P. So this is P2. So this is point 2 that you want to find. This is the current point, current position. So your current position multiplied by your rotation, so you will get a new position. So this is your current position, X, Y, Z. This is X, Y, Z. X0 kan? X0. Tak ada value. So you ada Y2, Z1. Y2, Z1. So selepas rotate dengan, awak multiply dengan rotation metric, this one. So you will get point 2 punya, point 2 position or coordinate. So bila awak rotate, so awak akan dapat Y1, Y1 and Z2. Y1, Z2. So this metric has solved a long calculation using homogeneous this metric, rotation metric. You can solve to define the position of net coordinate after rotation. If not, if you calculate individually, manually, so you need to use a trigonometry. So I think the calculation is quite long because this contain two axes. And then if you going to rotate from P1 to this side, that means you rotate on Z axis. So you apply RZ formula. So you can easily define your new position. So you can easily define a new position of P3, for example. So for example, your robot, your motor rotate P2 and then rotate to P3. So you only multiply based on which axis is rotate. So you multiply with this formula. So homogeneous is quite easy lah. It's quite easy. The only issue on homogeneous because every time you're going to find your position, you need to multiply with, if you have 4 axis or 4 joint, then you need to multiply with 4 metric. 4 metric. But for DH method, so you only have 1 metric. 1 metric. After you solve, you only have 1 metric. So the calculation is faster lah compared to homogeneous. Because you already calculate your robot design before you put into your control system programming. But homogeneous, you put all the metric inside your programming. If you have 4 joint, you put 4 metric. If you have 6 joint, you put 6 metric inside your controller. This translation. So translation is easier. Translation, because we're going to use homogeneous, we use 4x4 metric. So this one diagonal is 1, 1, 1, 1. The rest is 0. This is X, Y, Z value. X, Y, Z value. So you only need to apply to use these 4 metric only. 3 rotation metric and 1 translation metric. For example here, A to B, B to C. So for example, it's not remark X, Y, Z. For example, this is Z, X, Y. So from A to B, which angle you have rotation? Okay, this one from vertical slightly slanting. X also you have a different, it's not parallel. Z, Y also is not parallel with this Y. So that means each axis have a rotation. Each axis need to be calculated. This one, and this one is not parallel. This one is not parallel. This one also not parallel. So that means your calculation is long because the orientation of each frame is different. Orientation of each frame different. Unless if one, for example, the Z axis here is vertical. So that means you know that frame B rotated on Z axis. So it's easier lah. So your calculation is shorter. But now you see all axis is changing. So when all axis is changing, minimum is 2 axis is rotate. So 2 axis is rotate. And then you also have translation. Translation. From A to B, you have translation. If you only rotate at the same point, so you don't have translation. But now you have translation. So you need to multiply with translation metric. And this one also you have translation metric. T is translation. P is position. Okay. Example here, A from B to A to D to C. This one also has different angle. This is different angle between this and this. Also different angle. So a lot of calculation. This one, this is similar. Okay. So this is parallel. So this is parallel. For example, if this is X axis, that means this frame has little bit changing here because you have rotation on X axis. You have rotation on X axis. Between this and this, similar. So you can see Z is vertical, X is parallel with X, and Y parallel with Y. That means between U and B, you doesn't have a rotation metric. So you only have translation metric between U and B. So this one is simple lah. You only have translation. It doesn't have sine, cos. It doesn't have in your metric. You only have value X, Y, Z. Translation metric. Did the example. NOA is what? NOA is a name for your gripper frame at your gripper, for example. We call NOA. Actually, N is X, O is Y, A is Z. At point P, 732, that means 7 is X, 3 is Y, Z is 2 coordinate. Is attached to a frame NOA. Maybe this is gripper and is subjected to the transformation description described next. Find the coordinate of point relative to the reference frame at the conclusion of transformation. So ni transformation dia lah. Ada 3 step lah. Step pertama, rotate 90 degree about Z axis. That means your Z, apply your Z metric, rotation metric. And then follow by rotation 90 degree about Y axis. This apply your rotation Y axis metric. And last, follow by translation. Translation, apply your translation metric. This is translation. This is rotation. Y 90 and this rotation Z 90. But if the question said find coordinate point relative to reference frame, so we write from left, from right to left, right to left, huh? Right to left. So starting from 90 degree, rotate about Z axis, should we put here, right, and then rotate Y axis 90 degree, and then translate. So then if you arrange this, for multiplication, you can calculate both way lah. Whether you want to calculate multiply from left to right or right to left, doesn't matter. Both are right lah. Both are right. Only you need to arrange your metric. For this question, you need to arrange the metric from right to left. You need to put a right to left. This one is a similar question, but you have different step or transformation. So, but you still write from right to left because the question is similar. Find the coordinate of the point related to reference frame. Example here 2.8. Because find the coordinate of point relative to reference frame after the transformation are complete. This one, but all relative to the current moving frame. So you're going to do between frame to frame to find the coordinate relative to current moving frame. So you punya gerak-gerakkan frame awak tu, so relative to current moving frame. So this one we write from left to right. So this is step 1, this is step 2, and this is step 3. So you write, this is rotate, this one, and OA, this is Z, this is translation, this is Y. Then multiply. Multiply all this metric and multiply with the current position, current frame position. And then after you multiply, you will get a new frame position. So this one is X0 or NOA lah, NOA, X0 or N equal to 0, O or Y equal to 6, Z is 0. Z is 0. This is inverse kinematic. Inverse, how to find an inverse, apply inverse kinematic. So inverse kinematic, you will use the formula in lab 1 or lab 3 using a MATLAB. So this one you can read it by yourself. Inverse kinematic. So rotate at Z and then rotate at Y axis, and this one rotate at X axis. So rotate all axis lah. All axis. Rotate Z, rotate Y, rotate X. So you have one metric. This one is almost similar to DH method lah. Their calculation. Okay, homogeneous habis. So now we go to DH. Okay, homogeneous. Ada soalan tak? Any question on homogeneous? Semua boleh jawab ke?
Doktor.
Ya.
Saya nak tanya pasal position. Bolehkah terangkan sekali lagi?
Yang mana? Ya. Senang je homogeneous ni. Kali-kali je. Okey. Dia macam ni lah. Bila when you want to define your position of your gripper, so you have what we call transformation lah. Transformation. For example, like this one lah. So your rotation, your joint, this is one joint lah. One joint or one frame. So he said that joint or frame rotate 90 degree. First, rotate 90 degree and OA is Z lah. Rotate 90 degree. And then translate. So that means your gripper is move lah. Move. X4, Y -3, Z is 7, NOA. So you move your gripper and then follow by rotate Y 90 degree. So first your instruction is move, rotate your gripper 90 degree. Rotate your gripper 90 degree. Counterclockwise lah. 90 degree, that's mean counterclockwise. Turn counterclockwise 90 degree and move 4 -3 7. Move based on your translation. And then rotate 90 degree of Y axis. So rotate 90 degree. So and then define your position from the current position 732. So that's mean you use this formula Z rotation metric, and then apply translation metric, and then apply Y rotation metric. So then multiply with the current position. Current position is at 732. NOA is 732 or XYZ 732. So you multiply with this current coordinate, you will get a new coordinate of your gripper. Kalau tak tahu lah, tak mana nak susah, macam senang pun. So you apply rotation metric, 3 rotation metric and 1 translation metric. So multiply with the current position, you akan dapat a new position. Sama lah macam ni.
Ini position satu frame lah. Jadi ni position untuk satu frame lah.
Betul, satu frame. Tapi kalau nak kata satu frame tak juga. Ini sebab dia bagi tahu, katalah awak ada robotic arm tu 3 sendi. Ini dia tak, it's not informed that this is 3 axis robotic arm, 2 axis robotic arm. Because based on this translation, if you only have a gripper, so macam mana kita nak translate? Kita nak translate macam mana? So sebenarnya actually this is a robotic arm lah. So this robotic arm have many axes. So that's why you have a translation translation task. So task 1, transformation 1 is rotate. Only gripper exists. Gripper exists. And then task number 2 or transformation number 2, move your gripper to this distance. This distance. That means X you move 4, Y you move -3, NOA. When I say NOA, it's difficult to understand. So I said X, Y, Z lah. So 4 you move, X axis move 4 unit, and then Y move -3 unit, and then Z move 7 unit. So that means actually this is a robotic arm lah. Robotic arm. So he not state here robotic arm, but you know that your gripper can move. If you have only gripper, how your gripper going to move? So you must have arm, robotic arm. And then followed by rotation 90 degree about the Y-axis. Axis of the gripper frame tu lah. Axis of the gripper. So ini adalah pada gripper tu lah. Frame pada gripper tu. Frame pada gripper tu. So kalau awak tengok kat sini.
Okey, saya faham.
Kat sini lah. Sini lah. So axis tu duduk kat sini lah. So dia kata, he said that gripper rotate 90 degree Z axis, and then rotate Y 90 degree. So you can imagine that this N2 tu dia boleh berputar lah. Dia putar macam tu, lepas tu dia gerak macam tu kan. So dia tak consider semua ni lah. Tak consider each of the joint lah. Because he said move 3, move 4, move 3, move 7 tu kita program. We program the gripper move X4, Y -3 and Z7 tu. Kita imagine at this frame lah. At this N2 frame. Gripper frame. Dia duduk kat sini kan benda dia. Kita imagine di hujung gripper lah. Macam ni. So, kita rotate Z 90 degree, rotate Y 90 degree, and then dia kata move X4, X4, Y -3. So, daripada point ni lah. Y -3, and then Z 7 kot tadi. 7. Move lah, X, Y, Z tu. Sebab tu he said NOA because they going to inform that NOA is at the gripper. X, Y, Z normally on the joint, robotic arm. Robotic arm joint we call X, Y, Z. Kemudian kita we state that Z0 sini Z1, Z2. Example lah kan. Ataupun sini Z0 ni join 1 Z1, join 2 Z2, join 3 Z3. Sini NOA. Here we call NOA. XYZ we call NOA. NOA for gripper. Gripper or other end tu lah. Kita ada welding tip ke, we have welding tip, we have gripper, we have suction cup. So that one NOA. Normally they put the name NOA. This one is your main formula lah. If you want to change to 4x4 matrix, just put 0, 0, 0, 1 lah. 0, 0, 0, 1 and 0, 0. Tadi 1 lah. Hujung tu kan. Change to 4x4 matrix. Because homogeneous, we use 4x4. Ni sama lah tadi tu. NOA lah ni. Gripper kan. Nampak? NOA. NOA. So normally gripper we call NOA. Arm we call XYZ. Join arm. NOA. Tapi kalau join dekat arm, on the arm we call XYZ. Ni kan. So ni join ni nampak. The name is Z kan. Z, X, Y. Tapi on the gripper, they put different name. They put NOA. But actually, N is X lah. O, Y, A, Z. NOA. So DH another 2 week quiz test. So DH another 2 week. So next week we have quiz and then we break. We do a class or maybe we do a lab. So your lab will be started maybe 2 weeks from now the lab. But I have to attend exhibition 25. I'm not sure next week can do lab or not. Maybe we start our lab 25. I'm coming back from exhibition 28. That's mean after May lah, then we start our lab session. After May, we start our lab session. Or maybe early, maybe before 20. But it's too crowded lah. Between now it's already 11 to 20. We have quiz. You need to submit assignment. We have quiz. I'm afraid it's not enough time lah for doing the lab. So maybe end of the May, because the lab is very fast. It's not difficult. In 2 or 3 weeks, we can finish the lab already. So this is DH method. If you open any book, you can see this figure, DH. Because they want to show that in DH method, it's only have Z and X exist only. So they only use Z and X exist. They didn't use Y exist in the DH method. So just remind back, theta is for Z. Alpha is an angle for X. Ini pun terbalik ya. Susah bagi senang sikit. Alpha angle for X and then a distance for X. Theta is Z. D distance for Z. Okay, this is Z. Rotation Z, theta. Translation Z. Translation Z, this is Z axis. Yang red color is Z axis. So translation along Z axis we call D. D. Say again. Translation along X is A. We call A. And then rotation of X axis. So this is X axis. This is X axis. Translation along X, the name is A. Rotation along X. Rotation along X, we call alpha. So this is theta. Distance Z. Distance for theta, Z. Alpha is rotation X. A is distance X. And then the technique for homogeneous DH method, so X must be perpendicular, 90 degree ya, perpendicular. So ni adalah Z axis. So X axis is 90 degree perpendicular to Z axis. And then you have another joint, robotic joint. So this X must be perpendicular to another Z axis, perpendicular 90 degree. And this X perpendicular to this axis, Z axis, and perpendicular to this Z axis. That's why because to get this X perpendicular to Z, you have angle in DH parameter table between X and Z. This is because your robotic arm lah. You design your robotic arm bending 90 degree, for example, or you have angle 90 degree, the fixed angle. For example, this one lah. So you rotate Z, that's mean theta. Rotate Z, so you apply Z rotation metric. And then you have translation Z, D. So that's mean you have translation metric on Z. And then you have translation of X. Translation of X. So when you translate X, so it become like this. Then you have rotation X. So you have rotation X. Okay. So combination of this rotation Z, translation X, rotation X. So you need to apply rotation metric tu lah. Rotation metric. Rotation metric Z, translation X, rotation X. Then you get one formula, metric formula. This is specific for the robot that you have been designed. So it's specific. If you change the length of robotic arm, so you need to recalculate back all this. You need to recalculate back. Because if you change the length of your robotic arm, so after you multiply everything, so the value here is changed already. So you need to recalculate. So this metric will be put inside your controller. So that means if any change on your encoder, Z encoder theta or alpha encoder X, so you will have instant result, instant position of your robotic arm. This is position. So it doesn't need to calculate like this. If you use homogeneous transformation metric, so your robot need to calculate between this and this metric, and then this metric and this metric and this metric and this metric. So you need to calculate 4 times, maybe 3 or 4 times. But if you use DH method, so your system, your controller just calculate using one metric form. So you will get automatically get your position of your robotic arm. So it's faster than homogeneous lah. This one look like homogeneous kan? Okay, for example this yang ni yang dulu kan. So join 1, join kat sini X0 to Z0 to Z1. So you can see that you design punya robot tu mula-mula join 1 Z vertical, and then join 2 Z1 is horizontal. So that means you have rotation. Rotation on what axis? Rotation on x axis. You cannot say y, because y we didn't use in DH method. If you see rotate, so rotate on x axis. So rotate on x axis 90 degree. Rotate on which direction? Counterclockwise, so 90 degree. And then from join 1, join 1 to join 2. So we see Z is similar, parallel. So no change on Z, but you have theta 2 because you have motor here, theta 2. And then you have length from Z1 to Z2, you have length of X. X is A2. And then, do you have any rotation? No, you don't have rotation because this is the same direction, but you have theta rotation. Theta you have rotation, but you are in the same axis, but you have theta. So theta already included here. Then you have join between join frame 2 to frame 3. So we see Z is parallel, but you have theta 3, you have motor here, and then you have between frame 2 to frame 3, you have distance. The distance is A3, distance on X, and you don't have rotation on X. If you have rotation on X, that means your Z is changing. Your Z axis is changing. But now your Z axis is maintained. Then join 3 to 4, frame 3 to frame 4. So we see which direction of Z3. This is Z3. Where is Z4? Z4 is vertical. So from horizontal to vertical. So that means they have a rotation. It's not rotation by a motor, but rotation based on your mechanical design. So this is based on your mechanical design. So Z from vertical change Z to vertical. So that means you have mechanical design changing your joint direction. So you rotate on X lah. So that means your mechanical design change your Z to vertical clockwise. So clockwise is negative 90 degree. And from 4 to 5, Z4 to Z5, now you have another change, another rotation on X axis, but it's not rotation, it's your mechanical design of robotic arm from vertical Z to horizontal Z. So that means you have 90 degree because from vertical to horizontal here is counterclockwise. It's positive 90 degree. And then number 6, you don't have any distance, but you have only theta rotation. You have a motor rotation. Now you have a complete DH parameter table. After you have a complete DH parameter table, you need to multiply each of the row. So if you have a rotation on Z, so you need to multiply Z rotation metric and X rotation metric. So after multiply both metric, you get this answer, A1. And this one you have Z rotation metric and translation metric. So you multiply both metric, you get this answer. So you need to do each of the row. So this one you have rotation, translation, and rotation. Rotation Z, translation X, and rotation X. So you multiply all these three metric, you get A4. And last, you need to multiply all this, A1 until A6. So you multiply all this, you get one set of matrix lah, one matrix. That's mean this matrix contain from join 1 until join 6. So join 1 until join 6. So anything change between this is your encoder give a value. Each encoder give changing value, so you can define your position. Your position here in real time, on the spot or instant. So if you have changed any theta or alpha between this value, so you will get a value of x, y, z coordinate immediately. Kira ni, kau semua dah tidur apa? Semua dah belayar.
Ada lagi.
Ada lagi.
Ada.
Kau semua dah belayar. Tapi ni our test will be next 3 week lah. So next 3 week. Next week is our quiz. Homogeneous. So assignment, at least I hope you find the assignment for homogeneous and DH. At least you have idea little bit lah. Idea little bit regarding homogeneous and DH. So you have 90 student, 95 student. So at least you have 95 example lah. Make sure you do handwriting. Handwriting, only figure. If difficult to draw, then you can copy and paste the figure. But calculation must be handwriting. So it's more about practice lah. So if you do a handwriting, at least you think the metric, how we calculate the metric. I will give the link. Today it's quite busy today. We have visitor, and also I have to complete my registration ITech competition today. Maybe tomorrow lah, I give the link, Google Class link to submit your assignment. And then the quiz, I'm going to change the schedule because I have another group of this subject. So I'm going to propose on Wednesday lah, on this class session lah. On the night side, do you have any class malam tak? Hari Rabu? Rabu ada kelas malam? Hari ni ada kelas malam?
Ada statistik.
Alamak, ada pula tu. Tak apalah. Waktu lab session tak ada kan? Tapi awak ada group tu. Lab session ada group. Nanti saya check lab session, kalau boleh semua sekali join. Boleh lah kalau waktu ni penuh. Tapi saya nak buat waktu kelas, tak apalah. Saya try waktu kelas tengok. Kalau okey, hari Rabu lah. Nanti saya decide hari apa. Kalau waktu kelas memang okey lah sepatutnya. Cuma 16 tu tak boleh sebab cuti besok lah. 16 tak boleh cuti besok. Hari Rabu saya tak pasti. Sebab ada satu tu birthday Raja. Saya tak tahu hari apa. Hari Rabu ke Selasa tu. Kami tu Selasa. Sebab Nusti pun tengah tunggu sama ada Raja nak bagi cuti ke nak tunda. So hari Rabu lah. Nanti saya decide lah. Saya discuss dengan, nak check jadual dulu. Sama ada hari Rabu okey. Hari Selasa, hari Ahad, hari Isnin memang tak boleh. Hari Selasa takut cuti. Yang Rabu lah. Harap-harap okey tak ada cuti. Okey, kedua saya rasa saya kena berhenti awal sebab nak pakai sikit sebab saya lagi ada timbalan nak chancellor nak discuss robot kat sini. Dekat lab.
Boleh.
So kalau nak tanya next week saya akan buat revision to DH. Saya bagi example lagi lah untuk DH kan. Untuk next week saya bagi example lagi. Tapi awak jangan ambil example saya pula. Awak ambil example lain lah. You take another example. Tapi tak tahu lah, mungkin example saya tu maybe example yang awak juga. Saya tak pasti yang mana. Okay, so kalau tak ada apa-apa kita jumpa next week macam biasa. Tapi next saya akan inform quiz tu lah. Saya akan propose quiz dalam group. Dalam group lah.
Doktor.
Ya.
Saya nak tanya bagi slide yang doktor present tadi.
Oh tadi saya bagi dah.
Tak penuh.
Oh tak pernah ni full kan ni. Ni besar sikit saya share link kat tu. Saya buat Google Drive jap. Saya buat Google Drive.
Okay, thank you.
Saya buat Google Drive saya share link. Oh betul hari tu saya bagi yang ni noh cek apa? 1 2 3 noh. Okey. Google Drive. Saya tengah isi iTech-nya competition form tapi error apa entah. Google Drive.